Hello guys. So today we will take few more questions of maximum and minimum. So these are typical questions or good questions uh, deserving for boards and entrance tests also. So we will find maxima and minima or maximum minimum values of a given function, mainly polynomial functions, log functions, exponential functions, trigonometric functions. So we will use second derivative test, right? So we will use second derivative test. So we know the method. We have a equation of function. First we derive it for first differentiation and then put it as 0 and find the values of x and put these values of x in f double dash x, and if sign is negative, double dash sign is negative, then it will be local maxima. If we get positive sign, it means local minima. If we get 0, then we will go for point of inflection. So right now we have a question, find the maximum value of 1 over x to the power x and show that its maximum value is e raised to the power 1 over e. So this is important question. Now we have this function according to second derivative test. First we will get dy over dx, then we put dy over dx equals to 0, then go for second derivative and then test. So for getting the differentiation of this function, and this is variable and variable power variable, so we will use log method. So it will be log y and the log 1 over x to the power x, that becomes x log 1 over x, or you can say minus x log x. Right now differentiate 1 over y dy over dx, and the product rule on this, differentiation of x is 1, log x as it is. Now x as it is, log x is 1 over x, so we get this. So dy over dx equals to minus y 1 plus log x. So this is the first derivative. Now we put it as 0. So f dash x should be 0. Means minus y 1 plus log x will be 0. So 1 plus log x is 0. So log x is minus 1, that is minus log. So we get x log x is log e 1 over e. So we get x equals to 1 over e. So this is the value at which we will show the maxima, and its maximum value is e raised to 1 over e. We have function y is 1 over x to the power x. We have first derivative, dy over dx is minus y 1 plus log x, and we have value x is 1 over e. Right now we will go for second step and differentiate again. So we get d2y over dx square, and there is a product rule, minus differentiation of y is dy over dx 1 plus log x as it is, plus y as it is, and the differentiation of 1 plus log x is 1 over x. So minus dy over dx 1 plus log x and y over x. So this is our second derivative, in which dy over dx is 0, so it is 0. Y over x is positive, and with negative sign we get this is negative. So d2y over dx square is negative. So it shows local maxima. And the maximum value of the function at x equals to 1 over e. So we put it in this expression. So 1 over e to the power 1 over e. So we get e to the power 1 over e. So this is the maximum value. Is find the point on the parabola y square equals to 2x, which is closest to the point 1, 4. Like we have a parabola, and this is the point 1, 4. So we want the closest distance, we don't want this. So PQ is right now, this is closest. Let us consider this is x comma y. So we want point Q. So the distance d of PQ, that is under root of, you can place xy as a x will be y square by 2 and y is y. Okay, so we can collect the value of this. So that is x is y square by 2. So we place x as a y square by 2 and y as a y. So the distance between 1, 4 and y square by 2 and this, so it is y square by 2 minus 1 square plus y minus 4 whole square. And if we squaring this equation, then we get d square, and we put it as a z. So it is y square minus 2 by 2 whole square and y minus 4 whole square. So it is z. Right now this is y to the power 4 plus 4 and minus 4y square by 4 plus y square plus 16 minus 8y. So on taking LCM, we get y to the power 4 minus 4y square plus 4 and plus 4y square plus 64 minus 32y. So it is y to the power 4, this will be cancelled out, and minus 32y and plus 68 divided by 4. We will collect first derivative of z, that is dz over dy. So we have 1 by 4, and on differentiation we get 4y cube minus 32, and when we put it 0, so we get 1 by 4 4y cube minus 32 equals to 0. So 4y cube minus 32 equals to 0. So y cube equals to 8 and y is 2. So y is 2. But we want point. So we have equation y square equals to 2x. So put this value. So it is 2 square equals to 2x. So x is 2. So the point is Q point, that is x comma y, that is 2 comma 2. Right now we want to show this point shows the closest means the second derivative of this function should be. So when we go for second derivative, d2z over dy square, so it is 1 by 4 is common, and when you this differentiation, so we get 12y square, and on putting this value d2z over dy square at 2 comma 2, so the value of y is 2, so 1 by 4, and it is 12 into 2 square, so it is 4, then you get this, and this is positive, or you can say greater than 0. So if second derivative is positive, that shows minima, so it is closest. Point Q is closest. This is local minima, it's a bottom value. So PQ, the point Q is closest. This is minimum distance. So this is the question. We have function and we want to find the points of local maxima or local minima on this range. So this is the function sin 4x plus cos 4x. Right now, step 1, we differentiate it. That becomes 4 sin cube x cos x plus 4 cos cube x, and it is minus sin x. So on simplify, we get 4 sin x and cos x as common, we get sin square x minus cos square x. So 2 into 2 sin x cos x, and on taking common negative sign, so this becomes cos square x minus sin square x. So this is the formula of sin 2x, and it is the formula of cos 2x. So we get minus sin 4x. So this is first derivative. Now on putting it as 0, f dash x equals to 0. So minus sin 4x equals to 0. So sin 4x is 0, means sin 0 or sin pi or sin 2 pi. So when you compare these, you will get the values of x is 0, and on this 4x is pi, so it will be x is pi by 4, and on this when we 4x equals to 2 pi, so x is pi by 2. So the required value is this, because it lies between 0 and pi by 2. So we want x greater than 0 and less than pi by 2. So only this value lie in this range. So you have right now function that is fx is sin 4x plus cos 4x, and the first derivative as minus sin 4x, and you have a point x is pi by 4. So now you go for second derivative f double dash x, so it will be minus 4 cos 4x. So you will check the maximum minima at this value. So put this value for checking local maxima or minima. So at x equals to pi by 4. So put this value in this second derivative. So it is cos 4 into pi by 4. To cancel out this, so you get minus 4 and cos pi. Cos pi is minus 1. So you get minus 4 into minus